Jai Shri Gurudev. Good morning to everyone, students. In the previous class, we are studying chemical properties of alcohols. So, similarly, in this class also, we are continuing the chemical properties of an alcohol. But here, the next one is a cleavage of CO bond in alcohols. Okay. In last class, we studied about the cleavage of C and H. Sorry, O and H. No, in alcohol, for example, we are taking methanol. There is two types of bond, CO bond and OH bond. In the last class, we are studying cleavage of OH bond. In this class, we are going to study the cleavage of CO bond. CO bond. Okay, that is cleavage of CO bond in alcohols. The first chemical reaction is reaction with phosphorus trihalides. Now, in this case, alcohols is react with R bond OH. This alcohols is react with phosphorus trihalide, that is PX3. Phosphorus trihalide, it gives alkyl halide, that is take 3 currents of alcohol due to the presence of 3 halides, where X is nothing but halogen. This is generally represented as PX3, phosphorus trihalide. Now, R and Cl3, that is 3 currents of R bond X plus P, and there is 3 oxygens and 3 hydrogens, that is the H3PO3, called phosphorus acid. Phosphorus acid, and you get the alkyl halides. This is obtained from alcohol, which is react with phosphorus trihalides. Okay, this is the general representation of chemical reaction. Now take example. Take the example in place of X. You know where X is equal to what? Fluorine, chlorine, bromine, or iodine. Any. Take any one example. Here in place of R, take CH3. There is CH3 bond OH. What its name? Methanol. This methanol is reacts with the phosphorus trichloride. Take PCl3. There is phosphorus trichloride. So what do you expect from the following reaction? So similarly write same as it is. So in place of what is there? CH3. So that 3 currents of 3 currents here, 3 currents of CH3 bond. See here, the C and O bond is cleaved. Here also C and O, that is R and O bond. Now in place of OH, Cl3 is added. That is Cl, 3 currents of Cl, 3 into Cl, 3 Cl. Then P and 3 oxygens, 3 hydrogens, that becomes H3PO3. So H3PO3 is nothing but phosphorus acid, and CH3Cl is methyl chloride and methyl chloride or chloromethane. So you get like this. This is the reaction of phosphorus trihalide with alcohol. Similarly, take ethanol, CH3, CH2OH. Second example, take 3 currents, which is reacts with in place of PCl, we take PC or PbR3, phosphorus tribromide. So what we are expected here, the product is in place of CH3 there is CH3 and CH2. Right here, bond 3 currents of CH3, CH2, bond Br plus H3PO3. This is bromoethane or ethyl bromide. So this is the reaction of phosphorus trihalides with alcohol. Then next one, reaction with thionylchloride. The second one is reaction with thionylchloride, that is called as Doxel reaction. The thionylchloride is SOCl2 is the formula. Now similarly here, the alcohols react with general reaction. Alcohols react with the thionylchloride SOCl2 in presence of base pyridine PY, that is representation of pyridine. You get alkyl halide, that is R bond Cl, thionylchloride R bond Cl plus C, S and O, and here there is one oxygen, that becomes SO2. SO2 sulfur dioxide, this is gas. Show the arrow mark upside. Then there is two chlorine atom. One is here. This second one and hydrogen becomes HCl. This is also gas form. That is right gas. Here both sulfur dioxide and HCl are gases. They can be liberated easily and you get the pure alkyl chloride or alkyl halide. It means from the Dodge's reaction or from the reaction with thionylchloride and alcohol can get the pure alkyl halide, that is alkyl chloride. Okay, this is the application or merit of or benefit of this chemical reaction. Now example, take a methanol, CH3 bond OH. This is methanol. Now this methanol is reacts with the thionylchloride SOCl2 in presence of pyridine base. So what you get or what you are expected in place of our right CH3, that is only changing CH3 and Cl plus the remaining is SO2 gas plus HCl gas. Okay, so here we get methyl chloride. Methyl chloride, that is obtained from methanol. This is alcohol and alkyl. So similarly example, take one more. This is example 1 and 2. Example, take ethanol, CH3CH2 bond OH, ethanol. This ethanol is reacts with thionylchloride SOCl2 in presence of base pyridine. Pyridine is base, so you get finally pyridinium salts also. That can also be liberated easily. So not liberated, that can be removed easily. So what you get in place of methyl group is there. So you get a ethyl chloride CH3CH2 bond Cl plus SO2 gas plus HCl gas. Okay, very easy. These are the chemical properties. Already we have studied same type of chemical reactions in haloalkanes and haloaromates. Okay, so this is the method to prepare haloalkanes and haloaromates. You can be right if they ask there also. Okay, so this is the second chemical property that will be used to cleavage CO bond. Then next chemical property is oxidation property. Then the second chemical property of alcohol is oxidation. Here the alcohol is oxidized into aldehydes or ketone by putting the particular oxidizing agent. It means respective oxidizing agent. Okay, it means addition of oxygen or removal of hydrogens. That process will be takes place in this chemical reaction. Now example, take primary alcohols. Primary alcohols. When the primary alcohol is treating with an oxidizing agent, present oxidizing agent means acidified potassium dichromate or potassium permanganate or pyridinium chlorochromate or pyridinium dichromate or presence of chromic oxide. All these are the oxidizing agents. The oxidizing agents are, the oxidizing agents are acidified potassium dichromate K2, Cr2O7 potassium dichromate or acidified potassium permanganate, that is KMnO4, it is potassium permanganate, potassium dichromate, or we also use PCC, pyridinium chlorochromate, or we can also use PCD, PDC, pyridinium dichromate, and also we can use chromic oxide CrO3 in acidic condition, and also you can use the oxidizing agent like basic KMnO4, alkaline KMnO4. Okay, and there are so many oxidizing agents. These are some particular oxidizing agents were used to oxidize alcohols into aldehydes or ketones. Now primary alcohols, take the primary alcohols. These primary alcohols are bond OH or bond CH2 bond OH. This is primary alcohol which is oxidizing in presence of acidified potassium dichromate and potassium permanganate KMnO4. It gives haldehydes. Primary alcohols always gives haldehyde. So haldehyde is nothing but R bond C double bond O bond H plus C or C double bond H. Here there is a R C double bond O. This one. These two hydrogens and this oxygen becomes water. Water plus H2O. Get RCOH, that is RCOH. Okay, that is RC double bond OH. Get haldehyde. So similarly, this haldehyde which is on further oxidation, again oxidizing. Matte same acidic element for oxidize ಮಾಡಿದ್ರೆ this aldehyde gives a carboxylic acid C double bond OH. EO ಬಂದು oxygen hydrogen ಜೊತೆ add ಆಗುತ್ತೆ COH. This is what carboxylic acid. Carboxylic acid. We get carboxylic acid. This can also be reaction carried in presence of potassium dichromate KMnO4 or pyridinium chlorochromate or PCC or PDC. Pyridinium dichlorochromate or pyridinium chlorochromate. ಈ 4 reagents ಅಲ್ಲಿ ಯಾವುದಾದರೂ ಆಡ್ ಮಾಡಬಹುದು ಇಲ್ಲಿ. Okay, you get a compounds of the kind. So similarly, take an example CH3 bond CH2 bond OH. Ethanol ತಗೊಂಡಿದ್ದೀವಿ. Okay, we are taking ethanol. This ethanol is an oxidizing in presence of acidified potassium permanganate KMnO4. ಅಂದ್ರೆ acidic condition. H+ ಅಂದ್ರೆ acid. Sulfuric acid ಅದು ಬರೀಬಹುದು ನೀವು. Now this hydrogen and this oxygen become water. Or here also you can show like that. If you difficult to show, right, can be write like that. CH2, this hydrogen and this oxygen becomes water, like that. Water and remaining CH3 COH, that is CH3 bond C double bond O bond H. So this is ethanol. This is kethyl alcohol. We also called as ethanol, haldehyde, which is on further oxidizing. Then ಮತ್ತೆ oxidize ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, again oxygen is added, you get the CH3. This oxygen is added between O and carbon, hydrogen and carbon, that is C double bond O bond OH. So what you get, carboxylic acid. This carboxylic acid is ethanoic acid. There is two carbon atom, 1 2, hence ethanoic acid. Okay, this is the oxidation of alcohols into aldehydes, and which is on further oxidizing we get carboxylic acid. Similarly, this can also be oxidized in presence of this PCC or PDC. Now, similarly same reaction, this alcohols can be reacted in presence of the reagent like PCC, pyridinium chlorochromate, or PDC, any one among these two. Get same chemical reaction. Just you have to change the chemical reaction only. Okay, ನೀವು ಇದೇ ರೀತಿ PCC ಆದ್ರೂ ಆಗ್ಬೋದು ಅಥವಾ PDC ಆದ್ರೂ ಆಗ್ಬಿಟ್ಟು ಸೇಮ್ chemical reaction ಬರೀಬಹುದು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? Both are right. This is the oxidation of primary alcohols. Similarly, take the oxidation of secondary alcohols. The second one, oxidation of secondary alcohol. Take the secondary alcohols like R bond CH bond R double bond O. Sorry, double bond OH. This is secondary alcohol. I am writing the secondary alcohol. The secondary alcohol is oxidizing in presence of this chromic oxide, CrO3. Chromic oxide. This is the best oxidizing agent to oxidize secondary alcohols into ketones. Now here see hydrogen, OH and hydrogen. This becomes water and remaining is RCOR. That is RCOR plus H2O. Okay, this is called ketones. Secondary alcohols always gives ketone. Okay. Then which is on further oxidizing, you get the carboxylic acid. Carboxylic acid which is less than 1 acid. Sorry, less than 1 carbon. Then ಮತ್ತೆ oxidize ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ carboxylic acid ಬರುತ್ತೆ COOH 2 equivalents. ಅರ್ಥ ಆಯ್ತಲ್ಲ, 1 ಕಾರ್ಬನ್ ಕಡಿಮೆ ಬರುತ್ತೆ, you get carboxylic acid. ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಈ ತರ ಬರುತ್ತೆ. ನಿಮಗೆ ಏನಾದ್ರು ಮತ್ತೆ ನಾವು ಆಕ್ಸಿಡೈಸ್ ಮಾಡಿದ್ರೆ CO ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಇರುತ್ತೆ, ಮತ್ತೆ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇದರಿಂದ ಆಡ್ ಆಗಿಬಿಟ್ಟು ಇದು ಸಿಂಪಲ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಆಗಿ ರಿಮೂವ್ ಆಗುತ್ತೆ. ಸೊ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದಿಸ್ ಒನ್, in case of our take CH3 COH bond H bond CH3 which is an oxidizing base of CrO3 chromic oxide. So what you get? So here this is carboxylic acid. By putting chromic oxide, you get ketones. So CH3CO, here H and OH becomes water. Its O is added here. You get CH3 bond CO, CH3 plus H2. This is what acetone. That is ketone. So which is all further oxidizing in drastic condition. So all these reactions is carried in drastic condition. Drastic condition means this difficult condition. ಅಂದ್ರೆ ಜಾಸ್ತಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಇದೇ ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡಬೇಕು ನಾವು. ಸ್ವಲ್ಪ ಈಸಿಯಾಗಿ ಕ್ಯಾರಿ ಆಗೋದಿಲ್ಲ. ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂದ್ರೆ ಬೇಗ ಆಕ್ಸಿಡೈಸ್ ಆಗಿಬಿಡುತ್ತೆ, ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಡ್ಯೂ ಟು ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಓನ್ಲಿ 1 hydrogen at secondary carbon, but in primary carbon there is 2 available hydrogens, and in tertiary there is no hydrogen, so it is most difficult. Okay, that we call drastic condition. Now again here under drastic condition it gives a carboxylic acid, that is CH3, this one, and COOH 2 equivalents. This is called as ethanoic acid. So it gives ethanoic acid. Okay, this is the oxidation of secondary alcohols. Similarly, take tertiary alcohols. Then similarly tertiary alcohols, that is COH bond R. This is the tertiary alcohol. This tertiary alcohol is oxidizing in presence of basic alkaline permanganate. There is potassium permanganate. This is reacts in presence of this oxidation under drastic condition in presence of alkaline. That is basic KMNO4 potassium permanganate. It gives ketones, that is called C double bond O bond R. 1 carbon is less. Right, the 3 hydrogens, 3 carbon groups ಇದೆ, 1 carbon group ತೆಗೆದುಬಿಡ್ತೀವಿ, ನಮಗೆ ketone ಬರುತ್ತೆ. So you get ketones from tertiary alcohol, which is all further oxidation in drastic condition, means particular condition at a high temperature. High temperature reaction ಬರುತ್ತೆ, you get carboxylic acid, that is 2 equivalents of COOH. You get the carboxylic acid. I write C acid, carboxylic acid. Okay, now this carboxylic acid is less 1 carbon than the parent carbon. See here 1 2 3 carbons is there, but here 1 2 carbons is there. It means only 1 carbon is less from the parent carbon. The prime horizontal product should be. ಇದೇನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಇದಕ್ಕಿಂತ 1 ಕಾರ್ಬನ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? This is the chemical reaction for tertiary alcohols when we are oxidizing with particular oxidizing agent. Similarly, example take CH3 bond CH3 and OH. That is tertiary butyl alcohol. This is under oxidizing in the drastic condition presence of alkaline potassium permanganate. You get a ketone like CH3 C double bond O bond CH3, that is acetone. Okay, here 1 methyl group is removed because no hydrogen here. so that the chemical reaction is very slow. Then which is unoxidizing under same condition, means above condition, get ketone, sorry, carboxylic acid, that's the CH3, C double bond OH. Or if you difficult to write that one, write like COOH. This is ethanoic acid. It is 2 equivalents you get here. 1, 2 carbon atoms, here 1 carbon atom, totally here 1, 2, 3 carbons is there. But see here 1, 2 and 2 times 4 carbons is there. How it is means here there is one methyl group, right? That will be present in the chemical reaction. It will be react and form 2 equivalents of ethanoic acid. So this is the chemical reaction of oxidation of tertiary alcohols. So remember, these 4 reagents are used to oxidize primary alcohols, and this is used to oxidize secondary alcohol, and this is used to oxidize tertiary alcohols into aldehydes and carboxylic acids. This is aldehydes and carboxylic acid. This is ketones into carboxylic acid, and this one also ketones into carboxylic acid. This is the oxidation.